Hi everybody, great to see a wonderful turnout. I've been in Canada only 8 years, but out of respect, trying to learn the French language. And so what I want to say to you right now is, Buenos tardes, amigos. Is it my pronunciation? Was that? My French pronunciation's bad. It's fine. Okay, so what I'm going to talk about, it's right here. Much of my content will be to the west of the Crown, in the West Kootenays. So you can consider that a bonus or a ripoff, either one. We'll start out with forest health plots. We have 4 forest health plots in Southeast. They're 50 by 50 meters in size. They're permanent, and we come back every 5 years to take a look at these plots, do the remeasurements. All the trees are permanently tagged and mapped. So here's the results from the 4 plots we went out last year. If you look at the green first, that's the most important part. That's the healthy trees, okay? So if we look at those 4 sites, we see that 3 out of the 4 sites had a decline overall in healthy trees. And this is mostly due to the blister rust. So not a big surprise there. But we also had some mountain pine beetle as well. That's MPB, that's mountain pine beetle. And the DSB is blister rust. That's an acronym for blister rust. So again, beetle only really impacted one site, and that's the site north of Kimberley. That's the red color. How does this compare to maybe some other surveys that have been done? Well, Brenda's going to be up in a bit, but why don't we go to the prestigious Canadian Journal of Forest Research 2013, okay? We're going to go in there and we're going to look at a similar study. And if you look at the graph, what was found was the high incidence of blister rust, especially down at 49 latitude. That's the border, near the border with the U.S. So this kind of was not a surprise either. So closer we get to the border, it seems to be, as I think Diana said, kind of ground zero for blister rust. And they also had mountain pine beetle and pine engraver beetles as well. And they mentioned that in the paper. In technical jargon, those 3 pests they refer to as a triple whammy. Canadian Journal of Forest Research. So this is for real. And I haven't published in several years myself. But after reading this, I'm inspired to publish. And so my study, since we didn't have beetle at most of the sites, and we didn't have pine engravers, I'm thinking we had about a 1.5 whammy in southeast BC in my plots. So here's some more new information, and Randy Moody gets the credit. This is the vast majority of this data is from Randy. And it's basically, we're going from west to east. There's west, we go to east. This is a percent of healthy stems or healthy basal area. And you can see that the health declines as we come towards the crown of the continent. This is very, very useful. Thanks, Randy. Okay, climate change. Well, Bob gave a great talk. Usually when we talk about climate change, we're talking and predicting the direct effects of climate change on whitebark pine habitat conditions, and we're modeling that. We did have a little bit on beetle and climate change this morning. And how about blister rust? Well, I thought I would try to get a sense of what might be happening there. And what I did was I took one phase of blister rust. It's a very critical phase. It's when the spores are transmitted from the ribes leaves to the needle, the basidiospores. This only happens under pretty restricted environmental conditions. And what I wanted to do was look and see, using weather data, how has that window changed maybe? It's usually in late August. And how has the conditions changed? Increasing, decreasing, staying the same? So let's take a look. So these are the 4 weather stations we had. And as you travel across to the right in time, you see it's beginning in 2012, we had quite a noticeable, pronounced spike in the number of hours that meet the conditions for the transmission of spores from ribes to the pine needles. A disclaimer with this, in that blister rust is a pretty complex disease, and it has a complex cycle, 5 different spore types. So I just looked at the one stage of blister rust, the transmission stage. But I thought this was pretty noticeable. And 2016, I'm eagerly awaiting to get that data in pretty soon. Oh, okay, cone production. So whitebark pine tends to be a masting species, which means it's kind of hit or miss. They put out a lot of cones one year and no cones the next year. So I have 3 sites that I looked at out in the Kootenays. Each line is a tree in this graph here. And we can see that we had pretty good synchronicity among trees. You can see when we have a low year, it's pretty consistent. And then just about all the trees are producing cones in those other years. So looking good, looking in sync, splendid, very nice. So what I want to do next is compare between sites, right? What's the synchronicity between sites, not individual trees? And so we have 3 sites here. Gray Creek Pass is one of those places that some of us went to on a field trip when we had this conference in Nelson. And we see, it's not looking so good here. Out of sync, really out of sync. Pretty much hit or miss this year, 2016. And I was curious about what the overall cone production might be. Are trees dying off and we're having a reduced cone production? But in this case, these 3 sites, not really seeing any evidence. It's just every year is different, and there's really no evidence of a downward trend. I threw a trend line on there, and it was slightly down, but I don't think there's enough data, and there was some variability, so not much of a conclusion there. I think if I had done the cone counts in my forest health plots, which I showed earlier, we probably would see a decline in those plots, so I'm not sure how representative these particular stands are. Okay, blister rust screening. So this is something that we are doing in Canada, and this is the team up here. We've got Vicki and Randy. They've just retired, and this is all done up at Kalamalka, which is up the northern Okanagan Valley when you get into Canada. And we are actually doing the inoculations here. So we take the ribes leaves, and when we get the conditions just right again, and the spores drop onto the seedlings. And basically we're trying to kill them. And we outplant them. Outplant them into the big boxes. These boxes, the funding for these came primarily from Parks Canada, so thanks, Rob. So they're out there at Kalamalka, and we monitor those seedlings every year. I'm not going into detail on this because a lot of you folks have seen this several times on how we do rust screening. But we are starting to see results. And before I forget, I do want to thank the U.S. Forest Service, who have been so helpful for us. Folks like Mary Francis and Richard Snesko, they've really paved the way for us up in Canada to do rust screening up there. So our results, they are indicating, one more slide. This is just what we've done as far as the number of parents that we've screened. We're pretty low scale compared to the U.S., but this is where we're at right now. And our results are indicating that most of our, not most, but about 50% of the parents that we've screened are showing signs of resistance. So we're pretty pleased. This looks very promising. Okay, this is nice. We're going to put the graphs behind us now. Going to put the tables behind us. We're going to go for a little helicopter ride, okay? And so Whitefish, down here, here's Whitefish, and Fernie. So we wanted to go for a recon, or if you're in Canada, it's called a recce, right? I had no idea what they're like, let's get in the helicopter, do a recce. That does not sound good to me. But that's how it's set up there. So we wanted to check out some of the crown. And so we wanted to fly Fernie up past Barwood and down a little. We did a big loop. I'm not too familiar with the crown up until this summer, and I wanted to catch up. And so I brought Randy aboard, Randy Moody, and Don Piggott. And so we're here at the helicopter. The pilot is kind of going through his checklist. Canadian helicopter pilots, very astute, very coherent. They did not serve in Vietnam. Okay? Some of you older folks know what I'm talking about, who have flown. Okay? So we were pretty excited to have this whole situation. So we get up in the air, and we're looking at new territory to me. I usually get airsick, and this was all new, and so I was very excited. I was just enjoying it. But we were seeing some whitebark mortality, some inaccessible stands we hadn't seen before. I'm feeling really good. Then the pilot says, "Okay, we're gonna land." Like that wasn't part of the plan. So there's a landing coming up, and Randy is like struggling with his belt. He's getting ready to land and get out of the helicopter, and I don't know what's going on. Beautiful meadow appears. We drop down, and I'm staying in the helicopter enjoying this beautiful meadow view. The pilot says, "I'm getting out, don't touch anything." It's like, not a problem, because the thing's still going. And I'm enjoying the view. And then I noticed that these guys just needed a nature call. I was paying for the flight, but trying not to think about that. So we're not shy about this in Canada. When nature calls, we answer. And if you ever drive along the Trans-Canada Highway, you're going to see something. And this is now you know where we get the term hosers. Okay? So we got back in the ship, and we started seeing more things. And on a serious note, we're seeing the handiwork of humanity. There's a lot of logging that has happened in the whitebark pine zone, and it continues in whitebark pine. we were also seeing, this is a photo I took again on this trip. This is not above the timberline. This is not alpine. This is mining. We have a lot of coal mining in the Crown in British Columbia. And here's a whole separate area we flew by. We weren't looking for these things. We just kind of had a loop planned. And this is what we can see. So I am really glad that we are talking with the timber companies and with the mines. So the intention is to work together to hopefully conserve whitebark pine wherever we can. So I'm not trying to point the finger. I'm just trying to show what we're seeing from the air, and glad that we're mutually aware of whitebark pine. Okay, I'll go back to those 4 forest health monitoring plots in the Kootenays. On my recent visits to these plots, I went up to the one up there. Remember, that's where the beetles hit, up there by north of Kimberley. Went back there, and there was trees that had been marked in my plot, painted. I didn't do that. They were newly painted trees. And in the plot, outside the plot, all around the plot. And it turns out that that is a planned timber harvest. Okay? And since then, I've talked to the timber company, and they're very aware of it, and they want to ensure that that plot is spared. Another plot I went up to, right by Nelson. It's the nearest one. That's where I live, in Nelson. Went up there, and I saw this. I took this photo last week. There's flagging and a tag on a tree in the plot. There's survey string going through the plot. Okay, that is from a mining company. Okay, so what are the chances of 2 out of my 4 permanent plots? Am I a lucky guy or what? So this is what the reality is in southeast BC, and I'm glad that the awareness is being raised, because we have work to do. Okay, so I'm going to summarize here. Co-production. So within sites, the trees are generally in sync, and there is some variability between sites. Aerial recon. Okay, conspicuous mining and harvest up there. We also saw quite a lot of dead whitebark pine too, unfortunately. Climate change. Favorable conditions for the spread of blister rust may be increasing. And blister rust resistance. About half of our candidate trees are showing resistance. And there's different ways you can measure resistance, but that's our overall takeaway message on blister rust. Okay, so winding down now. I don't like to brag, but I want you guys to look for my new journal article coming out, Canadian Journal of Forest Research. Here it comes. Okay? Sorry to brag. And that's the end. Thanks.